This is about name entity recognition. Bhaskar and I will present it together. I should alert you that it's a very high-level presentation, but any detailed and technical discussion after that would really be interesting. So a little bit. Okay, so a little bit of for those who just came for the first time. As we said, most of us are working in Meltwater, and that's how we are connected to name entity recognition. So what we do as the basic idea in Meltwater is that we are doing media monitoring, and the vision that initiated the work of media monitoring in Meltwater is that as a manager or as a customer, when you get your morning cup of coffee and you sit in front of computer, meanwhile you get load of information from the web, and you should be able to get some insights in order to make informed decisions. And what we want to do is to build a system to help you to make those informed decisions. So meaning that we want to build some insights. And for those insights, of course, we need to extract data from the documents and provide enriched documents. So this could be like the things that you are looking for could be like looking for competitor of your company, or could be searching for your own brand, how its opinions growing around the world about that, or looking at the leads, or looking at the product reviews, and so on. And here is like how this insight that we provide look like. So these are like, let's say a customer is defining a search that I'm looking for articles that are about this and this, but not this and this. So you give some search items, and then you get some related articles. In this case, it's about the SpaceX and the United Launch Alliance. And then you can see the media exposure over a specific period of time, and you can find the trending thing. And then you can select also to read later, right? And already from here, you can find out that, oh, name entity where is important. Because to build all these things and extract these things, we need to find the name entities. Yes?
Can I ask you a short question?
Yes, of course.
I'm wondering, who's the customer? Is it you talk about the potential customer who's searching for something that you will provide, or is it a real customer who actually going to buy something? Or
okay,
so I'm just wondering who the actor is that's potential.
This typical slide of Meltwater, I can show you this one. I didn't use it because I've used it last time. But these are like some examples that, for instance, Securitas company uses Meltwater to find out about new instances of vandalism and break-ins. Often the victim is in need of services. So they can find trends in the news, and then also search look for the break-ins. And this can be like the target would be more social media than like news articles in this case, for instance. Then Kimberly uses Meltwater to help determine how public perception of a certain ingredient chemicals will influence adoption and sales. So these are examples of the customers that we are dealing with.
Thank you. So
And could be in different levels.
It's a kind of intelligence people in companies. That's
could be at any different level. Could be a professor at university is looking for related articles, or could be a higher level manager, or could be a middle level manager. It depends on the company. Could be a marketing sector of a company, or could be HR of a company.
Okay. Thank you.
Okay, and so then another way of presenting them is like to say what are the sentiments or media exposure about different companies, for instance, about Spotify, Google Play, and Beats Music and Pandora, for instance. So again, you can get some idea of why these are actually applications of name entity recognition in real world. But what is name entity? Non-linguistic definition, and also again, it's not a very accurate definition. I'm defining it according to the use cases that I have. Otherwise, I have to be very specific, and I should probably bring, I don't know, like 10 pages explaining what is it. But when we are talking about name entities, we are talking about referable entities. Usually there are proper names, and so for instance, when we say, I know this man, man is not a name entity, but he might be Charles, although there are several Charles in the world, but in the article when we are talking about Charles, it is referring to a specific person, so therefore we say Charles is a name entity. And then it can be a single word or it can be a multi-word, and it's not always only referable nouns. It can be also things like nationalities and languages as well. In some definitions, in some definitions not. So he is Swedish, then Swedish is also a name entity for us. So now we think our definition. Then let's see what is NER. You want to continue?
Yeah. So as Sahar said that you have already seen some kind of basic definition of NER. So now here you can see a bit more clearly what is the NER. So so the point here is you see that what Sahar was explaining, that when we have these specific names, like John lives in Stockholm and he works in Ericsson, then we can categorize the named entities like John and Ericsson into these person, location, organization, miscellaneous product, like these categories. Or it can be a lot of other categories, like in some use cases they also refer to events, for example. Okay, so considering this, you can see that what the idea here is we want to develop an algorithm which can extract these named entities from a text. So that is the important question we want to ask, that how we can develop an algorithm which can find like John is a name entity, Stockholm is a name entity, and Ericsson is name entity, this kind of things. And also the other task is that how to categorize that particular name entity into these groups. So in Meltwater we choose like these 5 categories, but I mean it can be extendable to other categories as well. Okay.
This is a very, the categories are very domain oriented. Like when you are working with medical documents would be very different, or if you are working with social data, usually in social data they have a totally different categorization and wider range because of the people who are actually generating those data. But in news article, especially considering the customers, usually these 5 categories will help. And then if you look into the state of the arts, most of the results that you see or analysis that you see, they are from the 4 first: person, location, organization, and miscellaneous.
Okay, so going to the next slide, it's like like we just want to here tell you a brief idea that why we need NER. So probably it's a German text. So basically, you see that okay, there are some text, and from there, if we know what are the named entities, we can find out some informed decision. So in the next slide, you can see that okay, we have some kind of these highlighted parts are kind of named entities, and there you can see that all these data like this 5.76 euro or this 4.8%, so these are always associated with a named entity. So looking at the document, looking at a news or a blog, we are actually want to understand sometimes that what are the things associated to the named entities, and then kind of getting some insights from there. So here we try to tell you that, so this is one of the applications that if we can find out an automatic named entity recognition, then we can actually uncover quite a lot of insights that are associated with that named entity. So now moving forward, so here is one more application. So it's like sentiment analysis, document level sentiment analysis. Sometimes it's not very useful. Why? Because let's say this last Halloween, Pepsi first gave this ad, and then there were a lot of blogs saying that this Pepsi frightens or spooks Coke with this Halloween theme ad. Then there are a lot of articles. Now the point here is, if you apply a plain document level sentiment there, you could find out it's a neutral document. But probably for Pepsi that document is positive, but for Coke the same document is negative. So here comes that if we can identify these named entities, then we can kind of understand that what are the sentiments associated to that entity, and then we can uncover this concept, entity specific sentiment, also called ELS, and that is probably helpful to some of the customers, like to give the same data to one customer in a different way and another customer in another. Okay. So this is another example, and there are like several other examples. And now, so you now kind of understand that what is name entity and what is kind of the use case, industrial use case a little bit. So now we want to know a little bit like how do we do that, right? Like it's a bit to solve the mystery. So there are like, mainly we are using supervised learning. It means like we must have a ground truth data, like some human or someone should label that, okay, this is name entity, this is its category. And to do that, you need to provide a good guideline. And well, that is also a bit challenging, that sometimes we also don't know what is what. We will come later on that. And then using this supervised learning, mainly in the state of the art, there are these, we highlighted in this way that, as you can see, the point here is to recognize the name entity. We need to understand a bit the associated relation with the tokens. Like if I say he is working in somewhere, so that somewhere should be an organization, or so there should be a kind of, so that's why you could apply this kind of Markovian, like a relation thing. So that's how as you see that the state of the art kind of having this progress, first hidden Markov model 1997, then conditional Markov field, and then finally conditional random field which appeared. And by far this is probably the best that they're giving the result. And there are a lot of variation, of course, but this is how the state of the art progress works. So we will see in a bit more detail that how this we can do it. Okay, so you so.
Okay. Yeah, but then as Bhaskar explained in supervised learning methods, we need to have good data and good grant truths, and of course you want to have a good coverage of different categories. If you want to train a model, your model should see enough data, and in this case, because we are dealing with two problems of detecting boundaries of a name entity in a text, and also finding the categories, we have large variations, and we need to also expose ourselves to different type of sentence structure and so. So we need a huge corpus, and it's very expensive to collect data, and also it's also hard to get human agreements on the text. So and usually when you see publications, they don't have very large corpus. And then what are the solutions? Then one solution is like in the state of the art that are like recently many people are working on, is that they try to make an automatic generation of these grant truths, which is like using, for instance, Wikipedia data. There are DBpedia and Freebase, where you can find for each page, for each entity that it has a hyperlink in the Wikipedia, you can find in according to their database what category it belongs to. But these categories, of course, are not exactly these 5 categories that we talked about. Then it needs some mapping. And it's not that easy that we are saying that, okay, we can just use all these links, because then there are several of the same entities that they are not highlighted, and many other challenges. So it is hard to get a good data, but people are trying, some researchers are trying to get good data out of that. And then another thing is that trying to combine supervised and unsupervised together, and one way of that is that to apply LLDA. Hopefully Bhaskar will present once about LLDA, so we are not talking about that here, but so the idea is that you have also a huge set of gazetteers, and then you do once detection of, you break the problem into 2 parts. One is that to finding the name entities, and the other is to finding the categories, and one part is supervised, and the other part is unsupervised.
Can I ask you one
yes.
more short question? I didn't really understood the corpus problem.
Mm-hmm.
You said it was expensive or something,
Mm-hmm.
but I didn't really understood why, what you're doing with the corpus. So you took Wikipedia as an example,
Mm-hmm.
but I'm just interested in what you actually are going to do with the
Mm-hmm.
corpus and the connection
Mm-hmm.
to what you then do with the analysis next step.
The thing is that, well, I said that's one way of the research to go, because the data, the real data, is expensive. So I can give you one example. So in the work that we do, let's say in English language, we need about 100,000 documents, let's say, to have a good quality of seeing different type of sentences, seeing enough of person, location, and all other categories. And it should be also realistic, you know, the data, news articles that also the customer will use. Otherwise, your model will not be trained for the customer, right? So the thing is that then you have to give this to students, for instance, or someone to annotate it, and then that would be expensive. Basically, in English, the problem is even worse, because in English, there are many students to annotate. You can put things in the mechanical Turk, although it has its own error. But it's easier. But then, if you want to extend your work to different languages, in some languages, there is no existing corpus to use, and then it's more expensive. We wanted to do it for Swedish. The company spent some money giving to students to annotate, and then we wanted to go to Norwegian, and the Norwegian was more expensive for us because students get more money. So either we should come up with using a smaller corpus, which doesn't generalize properly, or we have to go with an expensive solution, or using an alternative. Yes?
So these algorithms run them in parallel with something like a source, what did you just mention? Not Wikipedia, but of course Freebase. Yes. So you run them in parallel, and then the algorithms pick up the entities that weren't already defined, or is the end result the algorithm itself?
I have to say that we are in Meltwater. It's because we are trying to extend to different languages. Yeah. We are looking to Freebase, and we are using it. But as I said, it's very noisy because the challenge is not just untagged name entities, and then their derivatives as well. So fixing that is not that easy, but we are working on it. But one way could be, looking back and trying to find the same mention in the text. But that's an open project. Mm-hmm. Okay.
Yeah.
Yes.
So when you do this kind of linking and you find out which kind of categories, or you basically pick up the categorization from Freebase on the Wikipedia data or pages, if you find new categories because you start training on a larger popula and you find out that there are certain Wikipedia pages which miss certain important categories, do you also update? Do you update Wikipedia so you help that collective effort?
Again, this is still an ongoing thing, but then the thing is that no, we really haven't invested that much yet on the improvement in the in using the Wikipedia data. So it is still open work. Actually, currently I'm working on it. So we don't have really that updating. But one other thing is that we have to map them, all the categories, to our categories. And sometimes this is also not that easy. And of course, you also have this ambiguation. Maybe we can contribute there, but next work to do.
Will be kind of updated now with the Wikipedia.
Yeah, with the news.
Might be easier.
Yeah.
Okay, so talking about all these things, how does the pipeline look like?
Okay. So basically, I think this also could answer your question a little, like a bit more in depth, like as you were saying that how we can use the corpus, right? Like what we are going to do. So basically, this is a pipeline with the social NER, but it also the similar thing also you can apply with the editorial. So basically, it's like I'm explaining in a bit more naive way. Sorry for it. So basically, you see that here I have training corpus, right? So training corpus means like lots of sentences after sentences, right? So what we are doing, we are feeding that into first this tokenizer. So it is actually giving me those indivisible blocks. So those are my tokens, right? And then after that we are feeding them like this block, which is extracting features from all those tokens. So basically for each token, we are extracting internal token features. So internal token feature means like basically the morphological thing, like the full token, then maybe prefixes, suffixes, some part of the token, so all these things. And then we are extracting some external token feature, like for example, part of speech tagger, like this token, what is its part of speech. Then word cluster means like we are feeding that token into a already built huge cluster that is we call brown cluster, like that is built using millions of news documents, and we are finding out like what is its path from the root. So actually that cluster is based on the word similarity. So similar words should group into the same canonical subtree, for example. Yeah, we will come to that. So we are, and then also we are using gazetteers, like we are preparing, like that is also an external dictionary, that we are preparing like person gazetteer, location gazetteer, you know, organization gazetteer. So we are looking that if this token exists in one of them. So after we have all these features, we concatenate these features and we are putting a label, like if it is a name entity or not, you know. And then we are, when we have all this feature vector, so we are passing it to the CRF training, and CRF is doing the magic and giving us a model. And that model, in the same way, so up to now we have created the model. So in the same way, when we have a test document, we are passing the same thing. So we up to here we get the same feature. So we put that in the model, and model is giving us that this is a name entity and its category is this, because that's how the CRF is trained. So that is how we are actually getting the name entity recognition. Yep.
Okay.
The internal token feature, would that be like the lemmatized?
Yeah. So that is like the more, like, could be full token, prefixes, suffixes, lemma, some kind of part of token, you know. And then in CRF you can even add the rules, that you can add like this token with 2 previous and 2 next. So that's how you can actually get this semantic coherence, like this. So that's why I was telling that when it is working in, always this should be organization. So that's how in the training data you see, and that's how the CRF will learn with the annotation.
We now go like in detail into each of the boxes. So what does a tokenizer do? Is basically tokenizing a sentence. So what is a token? It's a group of sequence of characters that are meaningful together, and they convey a useful semantic. And one easy way is basically using space in English, which doesn't work in Chinese, right? And so because we don't have a spacing, and also using line breakers in English. But so that's a simple way, right? But it's not that easy, because then we have things, first of all, things like stop points, like dot, can be also, end of an abbreviation, right? So it doesn't necessarily mean like that's a end of a sentence, and then also sometimes it's, oh, sorry, I think I skipped one. Yeah. So then sometimes, actually a dot or double dot in some languages can be part of that meaningful thing. Like in Finnish, for instance, you have double dot en, which makes combined with the name makes a meaningful thing together, and that brings some challenges. That how do you tokenize that? Do you consider all as one token, or you break it down with that double colon? Then the other thing is that, as I said, we break a sentence into tokens, right? So then we have also a sentence splitter. Sentence splitter, usually in English we just say that, okay, things like exclamation mark, question mark, and the dot is the ending, right? But then when it comes to social, for instance, you have sometimes 3 dots and then continuation of something, and then this doesn't necessarily mean end of a sentence. And also, as I was mentioning, not all periods and dots mean end of a sentence, could be also end of an abbreviation. Yeah, so it's not, it has its own challenges. Then another thing that we said as an external feature is a part of speech, which gives us information about syntactical role of that token. If it's a noun, if it's a verb, what kind of verb is that? What if it's an adjective, or what kind of noun is that, and so on. Then here's an example. I am reading a book, and you see the different roles. And if you notice, both the exclamation mark and the point, both of them we say the same. It's not a mistaking the slide, but it have both of them. They have the punctuation role in the sentence. And then, as you see here, then we have book in the first sentence, that is a noun, and a book in the second sentence, that is a verb, right? And then with part of speech tagging, in English it's easier, but when it comes to languages like Finnish, then sometimes it's hard to extract. I see your head nodding. I think probably we share same pain with these languages. So sometimes it's hard to find a part of a speech tag, tag for these languages. Okay. Then you want to continue?
Yeah. So then the next, if you remember this feature block diagram, so one of the features we were
I have a question regarding the post tagger.
Yes.
That's basically shallow parsing of the sentence.
Shallow parsing is one level higher than post tagger.
Because post tagger itself is a classification problem. Like it itself has model.
Okay. It has a statistical model.
It's mainly you also use CRF.
Okay.
You mentioned Twitter as like the data source here, and like how well do part of speech taggers work with Twitter? Because it's not really
exactly.
What
So
are hashtags and what are
so we have a social post tagger.
So we are using because you can't really apply the same post tag. We tried. The performance is really poor.
Yeah.
How much was it?
I think
40%?
Yeah, no, 15 to 20.
Yeah.
Like only for the post.
For the only post tagger, 15 to 20% if you use only editorial.
Yeah.
Like what's editorial post tagger?
Because there were lots of these mistakes, spelling mistake,
or like language breakers.
So like this is one of the other features that I was speaking about. This is a gazetteer. So it's a simple feature. Like we have kind of dictionary, like for person, for location, for organization, and we populate the dictionary kind of offline from Wikipedia, from other sources. Like there are named websites, like for example, the Nordic name. There is a website where you can find all the male, female names and their frequencies, all this information. So there are ways, and also there could be problem also when you want to populate it. So, but anyway, so assuming that there is a way, so you can have these, and so when you have the token, you can search in these dictionaries and find this kind of features. Like if it is first name, male, female, or frequency. For location, you can find which city it is, country it is, population. So this.
Yeah, and then sometimes this population or frequency is important, because then you can have a name that is name of a person, but rarely is name of a person, is more name of a location. Like I'm not sure if Washington is a rare name, but more often it's referring in the news, it's referring to a location, right? And the same goes with population. Not in name entity recognition, but later on in disambiguation. If you're talking about Stockholm, then most likely you are talking about Stockholm as the capital of Sweden, not the small city in the United States. And sorry.
Yeah, I mean you can go to the next slide. Yeah, so I mean, so gazetteers are quite strong feature, because you see that if I find that entry in the gazetteer, I'm kind of sure that this should be in one of these. But also this is a bit misleading sometimes, that some of the entries can be present in both the lot of gazetteers. gazetteers, right?
The same as like Washington.
Yeah. So first, use gazetteer is a good thing, but the disadvantages are well, we have quite a lot of disadvantages. So the point here is like it's difficult to create and maintain. This is one of the part, and then like yeah. So depending on the category, like sometimes it appears in multiple gazetteers, then it kind of confuses the CRF. So it's a problem. And then yeah, like ambiguity is a kind of same, and then yeah, well, it's kind of the same. Okay, so then comes this brown cluster. Yeah, so brown cluster basically it's a kind of so brown cluster is a way to you know, to group the words which are contextually similar. Okay, so to do that you need to apply an unsupervised method, because you like the problem is simple that it is very difficult for us to read millions of documents and level, right? Like these and these. So we have to apply some kind of clustering technique. So I think it first proposed by Brown et al. And it's really a viral paper in NLP. Everyone cites this paper.
Just one of that. Brown clustering is one way of word clustering.
Yeah.
Yeah, like word to vector could be
also
another
nowadays,
way
like,
that it is becoming a hotter topic now.
Yeah, nowadays word to vector, like there is this Google release a 3.65 GB model which has 4 millions of words, and each word corresponds to 300 dimensional vector.
Has this been tried and like word vector in the NER? And like, do we know if it's better performance?
No, we haven't tried it, but it could be.
Yeah, it has better performance.
Have you?
It's written by Stanford renewable.
Yeah. I was just thinking like.
But I have a small doubt that, you know, that the problem could be that it can affect the computational time.
Yeah, it's high. It's computational more intensive.
Yeah.
Yeah. But it's interesting. The brown clusters where they could never be replaced. I mean, people kept on trying for like 20 years to come up with better models, and only very recently.
So we are kind of using this word to vector, but we are still finding like challenge to make the computational time faster.
N-grams you can use. It's much faster.
Yeah.
And it's almost the same curves.
Yeah.
Okay. What about like random indexing and things like that? Shouldn't that be able to do the same kind?
What?
Should ask the people on the front row.
Can you elaborate?
No, I can't.
Okay. Can you elaborate?
Yeah, but it's the same idea. It's basically, to me, word to vec is a projection of a
Context matrix.
Yeah, collocation matrix. So it's a projection of a collocation matrix down to a smaller space, and random indexing is also the same thing, but a little bit different technique.
So yeah, as you see, name entity recognition is a quite old topic in NLP, but still there are many things and many challenges to work on. Yeah, we should probably look into them as well. But for those who are not familiar with all this word clustering, and so, for instance, when we say contextually close to each other, means that, I know, like Monday, Friday, days of the week, they are contextually close to each other. Doesn't mean we can replace them in the text. Doesn't give us new information when we want to like find name entities, or like all the punctuations, they are contextually close to each other, and so on.
Yeah. So in the next slide, I think we have some kind of so here you can see that how this in a large amount of data you can, if you apply this unsupervised clustering, then it can kind of understand that which are the words that are contextually similar, like
and the idea behind is that it's like looking at a very huge number of tokens and big corpus, and clustering them based on the distribution of neighboring words around each each word that we have in those documents.
And this is somehow the way, like in the leaf node, you will always find the tokens, and then when you want to find its brown clustered ID, you find the path from the root to that node.
Mm-hmm. So it's just a binary string.
So you see that it's like these two are kind of the child of the same canonical parent, and then.
So they have less difference. So they are closest neighbors in the tree, so to speak. Okay, so all that we said seems still easy, doable, but then still there are some questions. What are the challenges in real applications? What's about moving to other languages, or what about moving to social domain? All these three things bring new challenges. One example of the first one was that, okay, most of the work in the state of the art have 4 categories, and the corpus that they have that I can use for training, they have only 4 categories. But in my domain, I would use a different thing. And if I work only with sport or with clinical data, I would need a different solution or different type of features probably. And then other languages, I gave already some examples with Chinese and Finnish, they have their own challenges. And then with Twitter, with Posttagger, we have challenges. And then we have also, depending on the domain, I just copied this from the slide. I like it. You see, we have also challenges like disambiguation that we didn't talk about it that much. That Washington can be a person, organization, location, geopolitical entity, a vehicle, or name of a faculty. And the algorithm should be either strong enough to detect that or have something on top of that to decide and disambiguate. Then comes with the challenge. If we can build a model that can be used in different languages, a multilingual one, or we have to adapt and pick proper features according to the languages. So yeah, I mean, like Chinese and Japanese words are not separated. Part of the speech, again, as we said, like in English, is different from other languages. And then, like in Finnish, we have more than 10,000 forms of verbs, which makes NER more complicated. And then shape feature is not always helpful feature. In languages like English, usually it's a good indicator if a noun is capitalized, then most likely is a name entity. But then comes with Swedish, for instance, that very often things are in a small letter, including like nationalities or name of the languages, and gets even more complicated with some other languages. This is my favorite comic that it's about inflected languages. So for those who don't know, like when we say inflected language, we are talking about like, you know, ending of the nouns, or they change the, they have a lot of derivations, and they can even change the, so look, for instance, one ending at the end of a noun may make it like in this comic they are talking about dog, so the English is, or British is saying a dog, and then like it comes that the dog, or dogs, or dog, or I don't know, 2 dogs, and so it changes in with Swedish, with German it gets even more complicated, and the worst time is with Finnish, and this is all the derivations that this is still going on, and it can be like one word can say with the dog, to the dog, or with all those dogs, or yeah. I tried to translate some of them, I didn't manage to check all. And one lesson learned for me was that at the beginning when I started name entity recognition, I was not looking at the language itself, but I learned that it's good to have some discussions and conversations with linguist people, real linguist people, and also understand properties of a language. Then, yeah, and maybe you want to continue with the social.
Yeah, so it's like then it comes like editorial versus social. So as we were saying that let's say that you have editorial NER and you take it and you apply social NER, so you see that a drastic drop in the performance. So more or less this graph is try to show these things, and then we can see that why it is happening. So basically you see that the social data, we are speaking about the Twitter data. So we are not speaking about Facebook yet, so because we didn't work on that. So the challenge is that the Twitter data are like tweets are very limited kind of source, like only we have 140 characters to say many things. And then we humans are kind of a bit innovative. So we mix up kind of lot of things, but we understand each other. So this is very funny. Like especially Indian languages, we don't use our own alphabet keyboards. So you can see like people speaking. I sometimes after I work here, I kind of surprise myself that I kind of understand everything it is written, but then I see that one word can be written in 20 different way, like 2 characters, 3 characters, full like spelling, and then people have different spellings because everyone trying to produce their. So we are innovative. So it's like that makes the algorithm's life more crazy. So that is like one of the thing, and then also you have wide range of topics. So in one sentence, one tweet, it can have movie, gadgets, place, and the company name, everything all together, and without any relation, like token relation. So those are, and also like we grammatically broken thing, and then so also there are a lot of misspelling. So it means that all those feature blocks would have hard time to find the actual features because nothing is good like oriented in a proper way. Yeah. So like here, I think Sahar mentioned some of the examples. Here you can see that like when you say that Jaguar's gonna like this episode of these, then Jaguar probably is a person, I guess. And then
I'm not sure in this context, but I know.
And then like here you can see how the problem comes, and then there is like those things, and then there are a lot of these hashtags and RT@. So it means that when you are working with Twitter, you have to develop a good pre-processing element or post-processing, pre-processing element to clean as much as noise you can, so that you can get this.
And your model should be able to deal with all these different things and misspellings. Like with this OMF and OMG, with that OMF actually means is about it's OMG, but it is misspelled, and it was also abbreviation, and it's really hard to find it. Then this means that you should probably consider, if you're using post, again, use a social one. If you're using a brown cluster, using a social one, and so on. Okay, you already know about these things, but we also need to evaluate the things. But one of the discussions in the name entity recognition is that should we look into FS-score, where most people look into, or we should look into precision? FS-score is a combination of recall and precision, but there are some discussions that maybe name entity recognition, when you want to evaluate your method, is basically better to look into precision, because for several reasons, and then the other thing is that you can have mistake in the category detection, or you can have mistake in the boundary detection, and you're penalizing when you see the results in the state of the art. You see they use usually the normal definition, and that means that they penalize the algorithm for both things. So if you read an article and you see the results, you have to check what is their definition when they provide precision and recall. And then sometimes it's like Apple co, and the co is not part of the name entity, but it is detected as part of the name entity. But I would say we should still give a thumbs up to this algorithm because it could detect it, but it's a partial matching. So yeah, just a lesson learned is a take-home message is that look into the metrics and definitions. And now we did some kind of comparisons to say what we have done for social data. It's still unpublished, so be gentle with the results. But yeah, we did some comparison with the state of the arts, and we used a huge corpus of like 76K of tweets, and we had like test data of almost 10K. And these are different categories that you see. And of course, I said everything, but this is FS score. This is sorry.
Precision recall.
Precision recall and yeah. And yeah, we start doing, I would say, a bit better. And changing the boundary with the state of art is not that easy, but we are doing fairly good, I would say, in social.
Can I ask you something?
Yes.
For example, NLP. Mm-hmm. How would you that abbreviation? Where would you locate that?
I would put it in miscellaneous.
Okay.
But I don't know. Probably I should discuss it with our product managers or so to see if they think it's a product or not. But I would put it as miscellaneous.
I'm asking because all this English abbreviation, mostly in 3 letters, it's a kind of pollution in all languages because it's a kind of over-leveled. It comes new abbreviations, yeah. and after 40 you start. Oh, I'm told. So isn't that a problem? Because people in different areas they know the abbreviations and the meaning of that can change a little bit, but it's a very big part. For example, if you take Twitter or short-term discussions. Mm-hmm. So have you an idea of a solution for that problem? Because it's very important to understand things when you read the text, a new thing, a new solution, a new product, a new idea.
Mm-hmm. The thing is that you are talking about a very important issue. Maintaining a good model needs update. That's one thing, but we should look into it as like the next steps. Updating gazetteers could be one way to look into it. Still, we need to update the model. But then there are also some other things. Is that in general, for us, for example, in our case studies, we don't use name entity recognition directly. So it's a very low buildable block for other things. It is important to have it very accurate, but also you get some other informations in a document which can tell you more about one entity. It's, for instance, this NLP itself can be about, help me out, neurological or yeah, something, yeah.
For example.
Yeah, so could refer to that or could refer to NLP, natural language processing, and that, depending on the context of the document, can be decided. So detecting, in other words, detecting the boundaries of deciding that, oh, this is probably a name entity is easy, but then for the categorization, either the model should be updated or we need to get other insights from the text to decide on that. Okay. Yeah, just as some conclusion, name entity recognition. For that, we need to have a good knowledge of our data set, application, linguistic properties of the language, and then we need to have a proper training data, and linguistic pre-processings are sometimes necessary, and then usually it's not, you need to look into several features, and then in the supervised approaches, usually CRF is a good solution, a good way to look into. And yeah, some suggestions for learning more, and that's it. But of course, I know some people like Ariel already. I asked him to present another time about name entity recognition from a different perspective. They use different approaches to look into name entity recognition. This is the way we look into it.
Yeah. So we, I mean, my approach is not exactly this structure, but we try to automatically extract the training data from Wikipedia and then using distributional semantics to aid in the process of the tagging. So trying to build an automated pipeline. Yeah, it's quite different.
Okay. So what do you think of having a break and then getting back for some discussion?